The aircraft's fuel system is made up of many parts. Let's begin with the fuel tanks. The center box and most of the internal wing area are made up of a huge system of fuel tanks. The main units are the left, center, and right tanks. This aircraft has a maximum capacity of 25,826 liters, or 5,681 gallons of fuel, weighing 17,395 kilograms, or 38,350 pounds. The ribs that support the wings also function as baffles with cutouts that allow fuel to move throughout the tank without too much sloshing. The fuel tanks are filled through a port in one wing. A refuel-defuel panel in the wing-to-body fairing displays fuel levels and controls the refueling process. Shut-off valves automatically open and close to ensure the tanks are evenly filled. The risk of fire is considerably lessened by replacing normal air in the fuel tanks with nitrogen-rich air. Bleed air valves on the main engines draw out pressurized air which is then cooled and passed through the air separation module. Here, some of the oxygen is removed, leaving a more nitrogen-rich substance, which is then pumped into the fuel tanks. This process is done after refueling is complete. Surge tanks at the end of each wing function as vents for tanks. The surge tanks have a NACA-style scoop that forces air into the tanks during flight. This maintains positive pressure on the fuel system while at the same time allowing for pressure changes depending on the temperature of the fuel and the elevation of the plane. These scoops also allow air to escape from the system during refueling. One-way flapper valves allow fuel to flow back into the main tanks, but not in reverse. Smaller collector tanks in each wing are always full in order to provide an uninterrupted supply of fuel to the engine. Let's take a look at how this works. The main fuel pump is mounted inside the jet engine casing. It is attached to a gearbox which is powered by the jet engine. In order to maintain the supply of fuel to the engine, many supporting fuel pumps work to transfer fuel as needed from the center and wing tanks to the collector tanks. These supporting pumps, called motive flow pumps, work by pressure alone. It is a simple and reliable system with no moving mechanical parts. Fuel from the main pump in the engine sprays through a nozzle into a narrowing tube, creating lower pressure in the chamber behind the nozzle which sucks up fuel into the stream. During normal operation, motive flow pumps transfer fuel from the center tank to the main wing tanks, to collector tanks, and then to the engine. Electrical boost pumps located in each wing act as backup if other pumps fail.